Hello everyone to this continuation stream of Draco REPL development. Let me quickly go through where we left off last time. Last time we started working on the REPL from scratch, and we didn't get too far. We got the basics down, but what we have is not looking like a REPL yet. We still need to feed in syntax trees manually into the REPL session object that we define in the main program of the REPL command line interface. And this is really not comfortable. But just to show you what this does, we basically declare a variable in the first line called x, which is a random number. And then to demonstrate that that we retrieve the same values from the previous executions, we reference the same random value twice. And if I run this, we'll get the same value printed twice, which is correct. Now, there are a lot of things that are not nice about this. First off, is that we need to feed in syntax trees constructed manually, which is really, really uncomfortable. And the second is that we need to explicitly reference the context by number in which the given entity was defined. So let's try to tackle one of these. To make this look more like a REPL, let's actually try to get the parser involved and not have to feed in syntax trees manually. So by the end of that, we should be able to just actually type in text and get the compiler back to us. So what I figured, first off, if you see there's differences with in the code compared to the last time, it's practically the same. I just reorganized it a little and factored out of better functions. So functionally, we're doing the same thing. So what I figured we would do to not expose the parser directly is to just have a public REPL result evaluate overload that takes in a line of text. And we would basically feed this to the parser, and the parser would parse this as a line. Now, that is not that simple because we want to support multi-line constructs. For example, if I open up C# REPL on one of my terminals, you can see that for single line things, it immediately evaluates. But the nice thing is that if I start defining something multi-line, it won't just say that this is an incomplete thing. It will actually let me type until I finish it. And only then it decides to finish the evaluation of that thing. So what we're going to do is define a new kind of character source for the lexer. And we're going to feed that lines, essentially, when the lexer needs it. Or we could do something even better, maybe, if we could pass in a stream or something for the lexer or as the character source. I'm not sure yet. We'll actually have to look at the parser internals to see which is the better solution here. So if we look into the lexer, you can see that it uses something called the source reader, which is just a simplified interface for basically keeping track of your character position if we are at the end of the stream, and a few utilities being able to peek into the source code as well as advancing in it. So we have like basically two implementations of that currently. Well, actually just one, which reads from memory. But we might want to introduce something that either reads from the source stream, so some kind of stream like like console in, or define a stream that a character source, sorry, that we could feed line by line. I'm not sure which one is better yet, but the simpler one is definitely this stream one currently. So let's try to actually do that. We're going to create a source reader implementation that reads from a stream reader. What's the naming convention? Memory source reader. So this is going to be a stream source reader. And we're going to have a stream reader fed in. Okay, I believe that's all we need, and then we just need to implement the interface. Is end, I believe, can be reader dot end of stream. Yes, really nice. For the position, we are going to implement that as a default implemented property, and we're just going to use it to keep track of the index we're at, and in case of a new line, we might reset it. I am not sure what to do yet about the position here. Advancing is really simple. We should be able to just read in from the reader. Read block. Oh yeah, but it wants to read into... wants to read into a buffer of that size. That's fine. Yeah, something like that should work. Obviously, we cannot save the allocation of a buffer here, since this is a streaming thing. And for peak, let's see if we can do that with the reader itself. It does have a peak, which is really nice. And I believe it returns -1 if there's nothing left. Oh, really nice. So we can do something like if peak is -1. Oh wait, but we need to peak offset amount. So we might need to introduce some look ahead here. Yeah, this might be a bit more complicated. Let's actually do something like so. We're going to introduce something called a peak buffer. So that's what we basically try to peek into, and we'll base all our operations on try peek, basically. So what we can do is while the offset is greater or equal to peak buffers dot length, that looks correct. We read a character. Okay. If it's a -1, we return false, and if it's not, we add it as a character. That looks correct. And if we manage to get it, we can just assign it and return true that we managed to peek. Okay. This looks promising, even though it's not really effective because we read character by character, but it's whatever. Actually, there's a smarter way than that. We can just do something like so. Yeah, okay. When Copilot starts to understand what we want, it's really, really nice. And for advancing, to not ignore the peak buffer, we can do something like this dot try peak Well, do we want to peek amount? We want to peek amount -1, and if amount is 0, we just want to return empty. And we can actually ignore the result. But we want to do something like that. Yeah, that's nice. That's nice. And we also want to remove this from the peak buffer. Okay, Copilot basically carried this this method for us, but it looks correct at first glance. So with that, we have a source reader that's hopefully capable of reading from a stream. So what we can do is define a new method here. That creates it from a stream. Okay, and let's do one with stream reader as well. Okay, that should be all that we need. And with that, we should be able to construct a source reader that we can then pass into the lexer, and that should take care of the parser as well. So we might want to actually discard this this kind of API, but do something like read from stream reader, I suppose. Yeah. Or we can just call it evaluate, and it will just read from it. I think that should work. So we need to construct the source reader that we just created. That's not what I want, Copilot. From that, we can actually create the lexer. Oh, and it needs a diagnostic table. For certain purposes, syntax errors are stashed in a different place. They're actually stashed in something called a conditional weak table. This is because when we are lexing and parsing, we do not keep track of the full positional information. So that kind of diagnostic structure is a little different, and we only translate to the API diagnostic structure when the full tree is parsed. So this is why the lexer and the parser actually take the diagnostic table. There's a question. Organ asks, does it do the lexing and stuff in chunks? Well, that really depends on what kind of source reader you're passing in. The lexer is a sort of token source. I think it implements that. It might not. You might be able to construct a token source from it. I don't remember our API, to be honest. Oh yeah, we do construct from it, which can be in memory. It can be from an enumerable, which can be a lazy or even an infinite sequence, and it can be streamed from a lexer directly. And the lexer one actually has a ring buffer as well as the lazy enumerable one, so you don't double lex or something. Yeah, we have both of these ways, or all of these ways, because for testing it feels wasteful to re-lex or parse some text when we construct from the tokens directly or something. So we just went with an abstraction here. So let's continue. We have a lexer. Let's summon the parser here. Yeah. These are stupid comments. I'll weed it out eventually, but I need to drive Copilot to not drive me insane from having to type this all manually. And we try to parse something that the parser doesn't have a concept of yet, which is either an expression, a declaration, or a statement. But the parser doesn't have capability to do this because you usually invoke a single method called parse compilation unit, which is right here. This is what you generally invoke. This is the only public function on the parser. And what that basically does, it tries to parse a bunch of declarations. But now we need a new thing that can parse a declaration if we're suspecting that the input is a declaration. If it's an expression, then we want to parse that. And if it's a statement, we want to parse that as well. And the differentiation between a statement and the expression will eventually be a problem that I really don't want to spoil yet, but we'll see. Now the hardest part is deciding what to call this method. I guess I'll call it parse REPL entry. I don't have a better name for this yet. I'll just leave it to do here. And here we need to decide what kind of thing we want to parse, because we really don't backtrack in the parser. Our parser is constructed in a really rigorous way where we never go backwards. We only go forwards. We try to be deterministic CF. I believe that's the category I'm looking for here, if we never need to backtrack. But fortunately, we have a couple of utility functions for this one. First off, there's an isDeclaration starter. If I remember correctly, yes, which checks if the thing that we are that's coming up, the token, is actually a declaration starter. And we even have a list of the tokens here for that. And that will be enough to differentiate declarations from statements and expressions. But statements and expressions themselves will be a different war that we'll have to fight. So let's do something like if is declaration starter this dot peak dot kind. Oh wait, peak I believe returns a token kind. Yeah, already. Okay, good. Then it surely is a declaration. You've only written some kind of a JSON parser so far and had to use backtracking there. Well, yeah, when you first write a parser, it's kind of hard. It seems hard, but when you've written like 50 of them, it becomes easier, and you get into the mindset relatively fast. But what I found is that if you don't backtrack in your parser at all, if you can afford that, of course, because your grammar allows for that, it generally simplifies it a lot, and I mean a lot. There's one more thing that we need to check for declarations, which is a visibility modifier. Because declarations can actually have a visibility modifier, which is generally just public or internal. We don't have a private keyword that's by default for everything. So we can just leave it to do here. We can deal with that later. It's honestly not important. But it's also not that hard to do, actually. So we can just do this, and I believe that returns an optional token, yes. And if visibility isn't null, then it must be a declaration as well. It must be a declaration in this case as well, and now it boils down to either an expression or a statement. And this is where a little bit of a complication comes in, because if our parser reads too far, or rather the lexer, we will prompt the user for a new line or a next line to enter without actually needing it, because there's a real difference when you type in 1 + 2 versus 1 + 2 semicolon. Oh wait, that's not actually allowed in C#. Let me think of a nicer example. Yeah, let's do something like int foo, which returns, I don't know, 3. So there's a big difference between foo as an expression and foo as a statement. The difference is this semicolon. And if we peek after the parser has parsed the closing parentheses and there is no semicolon, we'll suddenly just prompt the user for a semicolon and a new line, basically, when we really just meant that that we just want to evaluate this as an expression. So what I came up with, in my head at least, is that this is the only case where we ever need to look if a token has a new line after it. And fortunately, we don't drop any detail from the syntax tree, so this is perfectly doable. We can just look if the trailing trivia of the last parsed token contains a new line. So we can use that to differentiate it. So we can just start by actually parsing an expression and then promoting that sort of to a statement if we don't see a new line yet, because we know that we can continue parsing. Copilot, you're not on the top of your game today. I don't think we have a getless token, but we have a tokens attribute, I believe. Yes. Oh, and we have a last token. Like so. And we don't care about the token kind, but we care about the trivia, the trailing trivia. And we want this to be true. Oh, and this is unnullable. Wonderful. So we'll do something like so. So if this is a new line, we must assume that this was an expression. If there is no new line, it basically means that we can read from the same source without prompting the user. So we can try to peek for a semicolon. It might not be there, but we can peek for it. Actually, we might be able to say that we want to assume a semicolon here, but we just won't go there yet. this should suffice for now. Let's see if this actually works or will crash and burn. I'm not sure yet. Does Copilot see my new function? Yes, it does. Really nice. I believe syntax diagnostics needs a bit more work than this, but we'll check for syntax errors. We can actually check right now, but not like this. I don't even remember the structure, to be honest, if we have anything in here. No, let's actually make it a bit more useful. Let's do diagnostics.values. Oh, there's no values on conditional weak table. So what's this? Oh yeah, it's also an ugly nested list thing. So this is actually a diag list, to name it correctly. And this is a diagnostic. Or is it, what's syntax diagnostic info? Oh, it has an info, okay. So this is painful. Can we make it a little nicer? I think so. We can make it nicer by using select many. And then we can just have the any call of this here. This is a bit nicer because we get to pretend that we're working on a flat structure. So let's go back to the REPL session. So if the diagnostics have any errors, then we are going to report those, but it's not this simple because the diagnostic structure, as mentioned before, is different for reasons, basically. But I believe once the thing is parsed, we can actually translate the syntax diagnostic information into an actual diagnostic. Oh, and we can actually do this, which is wonderful. So what we can do is diags equals well, almost. We could iterate over the entire tree and call this get thing. The whole reason this is a bit more complicated is because we're working with red-green trees. If you don't know what that is, it's basically a term coined by Roslin to build a tree that's basically immutable but still walkable both ways. So this is why we cannot walk up for positional information during parsing, and this is why we have a different diagnostic structure for syntax nodes. But we can just do something really, really ugly here and say that we can do a node dot we have a pre-order traverse, that's fine. Dot select many. Okay. and we can turn it into an immutable array. What's wrong with this? Oh, because this is still a diagnostic information. Oh yeah, because we haven't wrapped it into a red node. Oh, it needs the tree. Huh. Well, we could definitely make it into a tree. And now we can do tree.root to get the red root of it, basically the wrapper tree. And oh, it really doesn't like the fact that now we have both the red nodes and the green nodes imported, so we might need to alias them. Let's alias API syntax node like so, and then we can. Oh, but we need to alias these as well, which is annoying. Yeah, let's bite the bullet for now. And that should mean that everything should be alright, so we can just call this .evaluate tree.root. Let's see what we managed to do with this. Let's remove this. Hopefully we won't need it anymore. And let's actually write the infinite loop. Yeah, why not? And we can do session.evaluate console.in. It's a text reader, not a stream reader. Oh, damn it. Does it have a reader? No. Okay, what we're going to do something real ugly and just change this all to a text reader. Let's see how the text reader API is different. It doesn't seem to have an end, which is sad, but let's assume that yeah, it does return -1. So actually the correct way would be to see if I'm not sure if we want to calculate the peak buffer here as is end. Oh no, we don't, we never do that. So this should be correct. Okay. That should have fixed it up. Yes. And does this mean that our main program is valid? Yes, it does. Let's do some niceties here and do console.foreground color to be red. And let's try this out. So let's try 1 plus 2, and we're hanging until we press a semicolon here, which is annoying. I guess we do peek ahead a bit too much. I wonder if the reader actually reads in the new line or not. Well, that should be relatively easy to check. Let's hook into the source reader, actually. Okay, and let's just do 1. Okay, that's good. And we try parsing a trivia, but that obviously won't be a trivia. Why are we peeking ahead again? Oh, because we try parsing a new line. Okay, but that's actually fine, because that's the same offset. So it's not gonna be a new line, it's not gonna be a space, not a comment. So we can finally lex the normal thingy. Okay, again, we just peeked at character 0, so that should be fine. And we arrive at isDigit, which is correct. And let's see if I can actually peek at offset 1. Yes, and I believe that's a new line. Okay. Our number parsing is really, really complicated. And we're trying to advance exactly 1 because we consumed that character 1. And we managed to parse an integer literal. Okay, that looks correct. And now we try to parse trailing trivia. Now this is where we're potentially screwing up. Okay, we try peeking 0, which is fine. We still have one thing in the peak buffer, which should be the \r. Yeah, that's good. And try parse new line. Peak as well, that's fine. And now we try to peek one more. And that's also fine because we should get a \n, which we do. Okay, that's also good. We managed to parse a new line. We're not in interpolation mode. Okay. We're peeking again, that doesn't matter. We're consuming 2, that's fine. That's actually really good. That's what we should be doing. And it was a new line, so we break. We don't parse any more trailing trivia. So that's also good. So now I have to wonder what's causing us to parse one more thing. So visibility is obviously null. Declaration starter won't parse anything else. And now we're at expression. I believe I know what the problem is. The problem is going to be things like binary expression. Because we are going to attempt to continue parsing. Yeah, we're going to jump into these, but that obviously won't succeed. But if we roll back here, I believe what we are doing is we fell into, oh yeah, call level expression. We immediately try to consume open parentheses, which is not ideal. We really want to avoid checking for all these places. What we need is basically some kind of lazy mode for the parser when it can bail out as early as possible. So we might need some extra work, introduce the parser. I wonder if there's an easy way to do that, but we're just gonna hunk at it and see where we land, basically. We're going to introduce a parser mode, and we're gonna have a none and a REPL mode. Oh, and let's make it an internal one, actually. We don't need to expose that since we don't expose the parser itself. And by default, this can be none. And I wonder what's the simplest of the simplest ways to do this, even if it means cheating a little. But I'm not 100% sure. I was thinking we could hack it into peaking, but that will obviously interfere with things like declarations. So I believe the best way is to just build a utility method for expressions specifically to check if a new line is encountered and we can bail out. So let's try to do that. Yeah, token level operators, this is fine. So we're going to pass in the last parsed thing, which let's look at parse call level expression actually to see what we need to check for. Parse expression itself. We might be able to just hack into parse expression since everything calls out to that. So yeah, that might just be the key to here. Oh no, because where we need to do the check is actually here in this while loop. So let's actually write it like so. Of course, if we're not in REPL mode, we will never bail out. So now we just need to basically infect the parser at certain places with this. If anyone has a better idea for this, it's welcome. So let's actually tackle expressions, because I believe we just need to take care of the main expression parsers. So pseudo statement level expression is simple because they have an introducing keyword. So there's no problem here. For binary expressions, we definitely do need to care. So if we can't bail out by result, and here it's basically the same thing for binary left associative operators. So prefix operators, we generally cannot bail out early because we have an operator. So let's go back to the parsers. We have a relational level expression parser. We actually need to check here twice because our relation operators are basically on the same level. They are not left or right recursive like in other languages. It's so you can actually write stuff like x less than y less than z in Draco, and that basically means that x is less than y and y is less than z. So it's all on the same level. So we can check if we can bail out early from with just left. For us, we can return left. Otherwise, we need to check if we can bail with right. This should suffice, I believe. Let's go back to parse expression. Let's see where else we need to introduce this. So we took care of binary left, right. Prefix we don't need to care about. We just took care of relational. So let's do call level expressions. Oh, here it's really simple as well. While we can't bail out using result, we just attempt to parse. Where is the references window? Oh, it's here. So let's check atomic expressions, but that should do a single peak operation. So that should be fine. Yes. Yep, that's fine. Let's give this another shot, but before we do that, we need to make sure that our REPL session instantiates the parser correctly. So we should do something like parser mode is REPL. And now we hope that we didn't introduce some regression in the parser in some way. So let's try 1 + 2. We still do the same. I wonder why. Let's actually hook into the parser and see for ourselves. We'll need this once for sure. Yes, because we hit the plus here, and then we parse another expression, which attempts to parse a binary left associative expression as well. Yes. Which will go down to prefix expressions. But obviously this is not going to be an operator. We're going to find an integer here, so that just goes down another level. Then we go to call level expression, which again just goes down the rabbit hole, and we finally find an integer, I believe. Yes. We've wrapped that into a literal expression, and now we will not be able to bail out for some reason. So here I believe we can bail out. Yeah, that's correct. Can we bail out here? We should, right? Yeah. Okay, that's also good. And we should be able to bail out here as well. Yeah, that's also good. We bail out here as well. Very good. We bail out here as well. Really nice. Here as well. So, oh, and this is where the problem is. I forgot to check here. Oh, because I believe I checked at the wrong place. I checked the total wrong place here. And yeah, we need to actually do it here. Let's see if this fixed it. So 1 + 2, oops, we don't need the breakpoint. Oh, there we go. And we get nothing. This is amazing. So let's try to define a variable. Let's see if that works. It does. And this is context 0, 1, 2, 3. So we should be able to recall its value by saying context 3.x, and we do. This is totally awesome. Of course, this is not ideal still. We'll eventually need to work on the fact that you don't need to type the definition context's name as a prefix. But that will be binder work, and it might be a longer thing that we need to do. So we'll leave that for later. For now, this is pretty good. I wonder if we should continue or not. Well, one thing we might want to work on is to make everything public by default, but I think this session is confusing enough already. So let's wrap up here. This is a decent point to stop at. Let's commit what we have. And before we leave, actually, let's run the automated tests for the compiler. It should not have introduced any regression since we use a flag, but just to be extra sure, it did not. Wonderful. I see that there's no one in the stream currently, which is fine, but that means that there are no questions. I won't be awaiting any questions here. I don't see any on Discord either. So thank you if you're watching from the VOD, and thank you everyone who jumped in at the start of the stream. We'll pick up hopefully soon this and make the REPL even better. Bye guys.